Hello everyone, this is Vijay Lakshmi. Here in this session, we have to discuss the model question paper 2, the continued part. Okay, in that last class, we already studied the model question paper 2 up to part C. Okay,
Okay,
here
let us
we
move on the part C. Okay, here there are total 9 questions are there. In this part C, total 9 questions are there. Out of 9 questions, we have to solve any 6 questions. Okay, each question carries 3 marks, that is 18 marks. Total from the part C, we have taken 18 marks. Okay, here there is a first question. Question number 30. Let L be the set of all lines in a plane and R be the relation in L defined as R is equals to L1, L2 such that L1 is perpendicular to L2. Show that R is a symmetric but neither reflexive nor transitive. Here they are already given. We have to show that R is a symmetric, neither reflexive nor transitive. Okay, we already know the relation, they already given. Okay, what is the relation? First, I have taken the relation R is equals to L1, L2. R is equals to L1, L2 such that L1 is perpendicular. L1 is perpendicular to L2. L1 is perpendicular to L2. First one condition I have taken here, that is reflexive property. Okay, by the given relation we can directly say L1 is L1, L1 not belongs to R. It means L1 is not perpendicular. L1 is not perpendicular to itself. Perpendicular to itself because every single line, okay, here there is a single line, this is L1. Okay, every single line is not perpendicular to itself because when we exist or when we taken the perpendicularity, must and should they have two lines. Okay, this is L1 and L2. If two lines are exist, then there is a perpendicularity exist, otherwise no. Okay, here by this one we can say L1 is not belongs to R. Therefore, what we say, R is not reflexive. Okay, R is not reflexive. Similarly, I can take an symmetric property. Okay, symmetric property. What we say, L1 is connected, L1 is perpendicular to L2. Okay, L1, L2 such that L1 is perpendicular to L2. Okay, here we are already taking the diagram here. L1 is perpendicular to L2. Then we can say L2 is perpendicular L1. Yes, that implies L2, L1 is also perpendicular to perpendicular L. What we written there, L1, L2 is belongs to R. That implies L2, L1 is also belongs to R4. Therefore, R is symmetric. R is symmetric. Then we have to check the third condition. What is that? That is transitive property. Okay. Here for the transitive property, we have three lines. Okay. We have to take on the three lines. First one is L1, L2. It means L1 is perpendicular to L2. Similar manner, I have taken L2, L3. Okay, L2 comma L3. L2 is perpendicular to L3. Okay, I can draw here L1 is perpendicular to L2. Then L, L3 is L2 is perpendicular to L3. Okay, then while observing the diagram, okay, what we say, L1 is not perpendicular, because while observing the diagram, what we can say, L1 is parallel to L3. Therefore L1 comma L3, such that L1 is not perpendicular. L1 is not perpendicular to L3. Okay, then we can written here L1 comma L2 is belongs to R, and L2 comma L3 belongs to R, but L1 comma L3 not belongs to R4. Therefore R is not transitive. R is not transitive. Then by these three property, what we say, therefore R is symmetric. R is symmetric, but neither reflexive, neither reflexive nor transitive. Neither reflexive nor transitive. This is the proof. Okay. Up to this much, you have to solve for 3 marks. Let us move on the next question. Question number 31. Here, solve 2 tan inverse of cos x is equals to tan inverse of 2 cosec x. Okay. Here, we have to remember the properties on tan inverse x. Okay. We already know the tan inverse x property. That is 2 tan inverse of x. 2 tan inverse can be written in the form of tan inverse of x. Okay, tan inverse of here not x, that is 2x, and x- tan inverse of 2x divided by 1 plus, sorry, 1 minus tan inverse of 2x divided by 1 minus x square. This is the one of the important property. Okay, I can use the property here. In place of x, we have cos x. Okay, in place of x here, 2 tan inverse. In place of x, there is a cos x. I can taken here. It can be written as 2 tan inverse of cos x can be written as tan inverse of 2. In place of x, we have 2 cos x divided by 1 minus cos square x. Okay, I can written here. I can written 2 tan inverse of cos x is equals to tan inverse of 2 cosec x. Okay, here by the property what we written, 2 tan inverse of cos x can be written as tan inverse of 2 cos x divided by 1 minus cos square x is equals to tan inverse of 2 cosec x. Okay, here also tan inverse x, here also tan inverse. Again by the property, I have used the property tan inverse of x is equals to tan inverse of y can be written as x is equals to y. I can use this property. By this property, I am directly written 2 cos x divided by 1 minus cos square x is equals to 2 cosec x. Here 2 get cancelled. Then cos x. Again, here 1 minus cos square. By using the identity law, that is sin square x plus cos square x is equals to 1. Here there is a 1 minus cos square x. It means taking cos square x on right side, we have sin square x. Okay, I can use this property. 1 minus cos square x can be written as sin square x is equals to cosec x. Then here cos x divided by sin square x. Now cos x, here cosec x can be written as cos x divided by sin square x. Same here I can write right side part. Cosec x can be written as 1 divided by sin x. Here this one sin x, this sin x get cancelled. We have cos x divided by sin x is equals to 1. We know the property cos x divided by sin x, it can be written as cot x is equals to 1. Then we want x value. Therefore, taking x on left side only, cot taken in the right side, it becomes cot inverse of 1. What is the value of cot inverse 1? The value of cot inverse 1 is pi by 4. The cot inverse 1 will be the pi by 4. This is the solution of the given problem. Okay. Before going to solve these type of problems, you have to practice thoroughly all the property and have to remember these all the properties are very important for your CET exam also. Okay. Now let's move on the question number 32. Find the value x if, okay, if x comma minus 5 minus 1, there is a 3 rows. Okay, here this is the 1 cross 3 matrix. Here there is a 1 row, 3 columns are there. So order of this matrix will be 1 cross 3. Here 3 cross 3. Here 3 cross 3 matrix. The order is not important. While solving, just I am first have to multiply. Okay, first have to multiply these two matrix. Okay, first have to multiply row by column. Okay, first have to multiply row by column. So I can multiply here x into 1, that is x. X into 0 plus 0. X into 2, it is 2x. Okay, now sorry, here I done some one mistakes here. Sorry, have to correct it. First taking row by column. Okay. Now I can take the multiplication. X into 1, it is x. Minus 5 into 0, it is 0. Next minus 1 into 2, minus 2. I have to multiplication taking row by first column first. First column, second row here. Because there is only one column is there. X into 0, 0. Minus 1 into 2, minus 10. Minus 1 into 0, it becomes 0. Here x into 2, 2x. 2x. Minus 5 into 1, minus 5. Minus 1 into 3, minus 3. There is a, here there is a multiplication. X 4, 5 is equals to 0. Okay. First taking the row with column, you will get the result. X minus 2 matrix. Then minus 10. Here 2x minus 8. Okay. Here 2x minus 8. Then again there is a matrix left here. Similar manner, again here also taking row by column, you will get the x value. Taking x minus 2 into x. Here x into x minus 2 plus minus 10 into 4 minus 40. Again 2x plus 2x minus 8 minus here plus 1 is equals to 0. While solving this equation, you will get the result. X into x square. X into minus 2, minus 2x. Plus into minus 40. Here plus 2x into 1, 2x. Minus 8 into 1, minus 8 is equals to 0. X square minus 2x plus 2x get cancelled. Here minus 40 minus 8. The answer is minus 48 is equals to 0. We want x value. I can take x square here, taking 48 on right side. It becomes plus 48. We want x value. Therefore, root of 48. Now, 48. This is also right answer. Otherwise, you can written 48 in a simplest form. Okay. Now, I can take 48. 2 into 24. 24 can be written as 6 fours. Again, 6 can be written as 3 twos. 4 is 2, 2 twos. So, it can be written as z is equals to 2 into 3 into 2, 2, 2. Okay, I will check now. 2 threes are 6, 6 twos are 12, 12 twos are 24, 24 twos are 48. So I can group the 2, 2 here. So I am taking outside. It becomes 2 into 2 into root 3. It can be written as 4 root 3. Therefore, the value of x is, therefore, the value of x is, the value of x is plus or minus, because of roots, the value is plus or minus root 3. The value of x is plus or minus 4 root 3 because of root. Okay. Now, let's move on the question number 33. If y is equals to 3 into e to the power 2x plus 2 into e to the power 3x. Most of the time, this question is not taken in 3 marks. Some may, okay, some the chance for taking 3 marks is less, because most of the time these type of questions will be asked for only 5 marks. Okay, first I will consider the y is equals to 3 into e to the power 2x plus 2 into e to the power 3x. Now, differentiate with respect to x. Differentiate with respect to x. First differentiation, dy by dx is equals to 3 will be constant. Differentiation of e to the power 2x. We already know that e to the power x will be e to the power x. In place of x, we have e to the power 2x. I am taking e to the power 2x. In place of x, we have 2x. Therefore, I can taking again differentiation of 2x plus 2 will be constant, taking e to the power 3x here. Okay, differentiation of e to the power 3x will be e to the power 3x. In place of x, we have 3x. Therefore, I can take again differentiation of 3x. Now, 3 into e to the power 3x. Differentiation of 2x will be 2 only, because 2 is the constant. Differentiation of x will be 1 plus 2 into e to the power 3x. Differentiation of 3x, 3 will be constant. Differentiation of x will be 1. So this is 3. While multiplication 3 to the 6 e to the power 3x plus 6 e to the power 3x. Sorry, I can written here. Here in place I have written 3x. This is 2x. Okay. This is dy by dx. Again I am taking differentiation. Again I can take differentiation with respect to x only. I can take differentiation with respect to x only. That is d square y by dx square is equals to 6. Differentiation of e to the power 2x. Again e to the power 2x. In place of x there is a 2x. I will take differentiation of 2x plus 6 is b constant. E to the power 3x. Again in place of x there is a 3x is there. I will take differentiation again. Now you will get 6 e to the power 2x into 2 plus 6 into e to the power 3x 3. Okay. This is d square y by dx square. Now I can take the equation, or while substituting the values in this equation, that is d square y by dx square minus 5 into dy by dx plus 6y is equals to 0. What is the d square y by dx square? 6 2 za. Here 6 2 za 12 e to the power 2x plus 6 3 za 18 e to the power 3x. Now I can substitute here 12 e to the power 2x plus 18 e to the power 3x minus 5 into, what is the dy by dx? That is here 6 e to the power 2x plus 6 into e to the power 3x plus 6 into, what is the y? 3 into e to the power 3x. Okay. 3 into e to the power 2x plus 2 into e to the power 3x. Now taking the multiplication, here 12 e to the power 2x plus 18 e to the power 3x minus into plus, it becomes minus by 6 30 e to the power 2x plus into minus minus 30 e to the power 3x plus 6 3 18 e to the power 2x plus 6 2 18 e to the power 3x. While adding the equation, here there is a 12 e to the power 2x is there. Here there is a 18 e to the power 2x. While adding 12 plus 18, you will get 30 e to the power 2x. Here minus 30. These are get cancelled here. Again similarly 18 e to the power 3x. Here also 18 e to the power 3x. Sorry. 6 2 12. Okay. Here 18 plus 12 becomes 30 plus 30 minus 30. This is also get cancelled. You will get the result 0. This is the proof of the given problem. Let's move on the Question number 34. Find the intervals in which the function f is given by f of x is equals to. Okay, we have to find the intervals here for the function, that is f of x is equals to x cube plus 1 divided by x cube. For this function, we have to find the intervals. Okay, first step, first have to differentiate ones. Okay, we have to differentiate ones, that is f dash of x. What is the differentiation of x cube? It becomes 3x square. Okay, plus what is the differentiation of x cube? That is minus 3 divided by x to the power 4. Okay, we already know that differentiation of 1 by x will be minus 1 by x squared. Okay, by this property, similar this property I can use here. Differentiation of 1 by x cube will be minus 3 divided by x to the power 4 while solving the intervals. Okay, while solving the intervals, we can take, while solving the interval, we can take the function, that is f dash of x is equals to 0. F dash of x is equals to 0. Okay, now you will get 3x square minus plus into minus minus 3 divided by x to the power 4 is equals to 0. Again, I will take minus 3 by x to the power right side. You take x square is equals to 3 divided by x to the power 4. While multiplication, taking the multiplication, 3 into x to the power 6 is equals to 3. 3 get cancelled. X to the power here 3 ones are 3 ones are. Okay, I am taking 1 on this side. X to the power 6 minus 1 is equals to 0. 1 can be written as 1. Okay, 1 can be written as 1 to the power 6. Therefore, now, or 1 can be 1 square, or I will taking the property here. Sorry, 1 can be taken as square by the property x cube of x square minus 1 square is equals to 0. While solving the equation, I can take or use the a square minus b square property. Here, a square minus b square means a plus b, a minus b. I can use the property here. A means x cube. Here a means x cube, that is x cube minus 1 into x cube plus 1 is equals to 0. While solving the values of x, while solving the values of x, that is x cube is equals to 1 and x cube is equals to minus 1. No, by this property, the values of x cube are x cube of 1 is equals to 1. Okay, 1 into 1 into 1. Therefore, the value of x will be 1, as well as while solving the equation, the value becomes 1. So, x having two values. Now, again return the intervals. Taking the number line, here this is 0, minus 1, minus 2, up to so on. Here plus 1, plus 2, up to so on here. For x1, okay, here from minus infinity to minus 1. Here for minus infinity to minus 1, that is minus infinity to minus 1. Then the second interval minus 1 to 1, and the third interval here minus 1 to 1. 1 to infinity. Now, I can return here by the interval, the given function, by the given interval, what we say here minus 2 minus 1. The function is strictly increasing, or the function is increasing. Here, minus, there is a plus, the function is decreasing, here increasing. I can return here the points. The points x is equals to minus 1 comma 1 divides the interval into three parts. Interval into three parts. Then in the interval minus infinity to minus 1 and 1 to infinity, the function f of x is increasing. Okay, or we can return here increasing, and in the interval minus 1 to 1, the function is decreasing. Okay, the function is decreasing. Hence the solution. Okay, let's move on the question number 35.
Question number 35. Evaluate integration of 3x minus 2 divided by x plus 1 whole square into x plus 3. Okay. Let us consider the equation, that is 3x minus 2 divided by x plus 1 whole square into x plus 3. Okay. Well, I can written 3x minus 2 divided by x plus 1 square x plus 3 of the form. Okay. Of the form x plus 1 plus b into x plus 1 whole square divided by x plus 3. Okay. Because the integration solving by using the partial fraction, by that property I can using the partial fraction property. Okay. Here x plus 1 square into x plus 3 can be written. There are three terms are there. One is x plus 1 and another one is x plus 1 square and x plus 3. There are three terms. That's why I want to check the three constant. One is a, second b and third c. Okay. So now while taking the LCM, what is the LCM here? X plus 1, x plus 1 square and x plus 3. The LCM is x plus 1 whole square into x plus 3. Okay. While multiplying x plus 1 square is there, while I'm multiplying a by x plus 1 into x plus 3. Similarly, for b, we can multiply x plus 3 because there is a x minus 1 square is already present there. And here for c, we can multiply x plus 1 and here x plus 1 square. Now on left hand side, x minus 2 divided by x plus 1 whole square into x plus 3. While neglecting this one by cancelling, you will get the result 3x minus 2 is equals to a into x plus 1 into x plus 3 plus b into x plus 3 plus c into x plus 1 whole square. Now we have to calculate the values of a, b and c here. Now first I can put x is equals to, while putting the minus value minus 1 in this equation, you get the b results. Okay, putting x is equals to minus 1, that is 3 into minus 1 minus 2 is equals to, here while taking the x is equals to minus 1, the whole value a becomes 0. Here also putting x is equals to minus 1, that is minus 1 plus 3. Okay, next plus c. While putting x is equals to minus 1, you will get 0. So solving the equation, 3 into minus 1 minus 3 minus 2 is equals to b into 3 minus 1. It becomes, okay, here 3 minus 1, you will get 2. Therefore, b value becomes minus 3 minus 2 minus 5 by 2. B value becomes minus 5 by 2. Similar manner, I can put x is equals to minus 3. Okay, here 3 into minus 3 minus 2 is equals to. Now, I can put x is equals to minus 3. You will get result 0. While putting here also, you can 0. Now, then c value becomes minus 3 plus 1 whole square. 3 into 3 minus 9 minus 2 is equals to c into minus 3 plus 1 minus 2 whole square minus 11 is equals to c into 4. Therefore, c value becomes minus 11 by 4. While taking here x is minus 1 and minus 3. Now, in third one, simply I can take x is equals to 0. Okay. Here x is equals to 0. Then the equation becomes here minus 2 is equals to, here x is equals to 0. You will get 1. Here x is equals to 0. It is 3. 3 into a. Now, plus x is equals to 0. It becomes 3b. Here x is equals to 0, it is c. While substituting the b and c value in this equation, the equation becomes 3a plus 3b plus c is equals to minus 2. Okay, I'm taking here. Okay, I can taking, we want 3a value. So 3a I'm taking here plus, what is 3 into b? What is the value of b? Minus 5 by 2 plus, what is the value of c? That is minus 11 by 4 is equals to minus 2. We want pure 3a value. That's why I'm taking all the equation on the right side. Minus 2. Here 3 into minus 5. That is minus 15. Taking on right side, it becomes plus 15 divided by 2. Here plus into minus. While taking the right side, it becomes plus 11 by 4. Taking LCM here, we will get 3 is equals to, there is a 1 present here. LCM becomes 4. 1 4 is 2, 2 is 4 1 is minus 8. Here plus 15 into 2. It becomes 30. 11 into 1, that is 11. 30 plus 11, it becomes 30 plus 11, it becomes 41. 41 minus 8, that is 33 divided by 4. 3 ones are 3 11s are. So what is the value of a? A value becomes 11 by A value becomes 11 by 4. Now, now substitute the A, B, C values in this equation. While taking the integration, I can consider this is equation. Taking integration for equation, this is 3x minus 2 divided by x plus 1 whole square, x plus 3 into dx. This is equals to integration of. So I can take the bracket. What is the value of A? 11 by 4 divided by x plus 1 into dx plus what is the value of B? That is minus 5 by 2 x plus 1 whole square into x plus what is the value of C? Minus 11 by 4 divided by minus 11 by 4 divided by x plus 3 into dx. Okay. Now taking the constant values outside, that is 11 by 4 integration of 1 divided by x plus 1 into dx minus 5 by 2 integration 1 divided by x plus 1 whole square into dx minus 11 by 4 into integration of 1 divided by x plus 3 dx. Okay. While taking the integration 11 by 4. Here, integration of 1 by x, we know that log x. In place of x, we have x plus 1. It becomes log of x plus 1 minus. Here, what is the integration of 1 by x plus 1 whole square? Okay, so I can solve here. That is integration of 1 by x becomes log x. Then integration of 1 by x square is equals to, so taking x square on, it is x to the power minus 2. While integrating this factor with respect to x, that is x to the minus 2 plus 1 divided by minus 2 plus 1. While solving x to the power minus 1, x to the power minus 1 divided by minus 1, that is minus 1 by x. That is integration of 1 by x square becomes minus 1 by x. Here in place of x we have x plus 1 is there. So there is minus 5 by 2 into minus of 1 divided by x plus 1. Okay. Minus 11 by 4. What is the integration of 1 by x plus 3? It is log of x plus 3 plus some constant value c. That is equals to, here there is a log. Okay. Log of, there is 11 by 4. Here minus 11. I can taking 11 by 4 as a common. So by the property of logarithm, that is log of m minus log of n can be written as log of m by n. According to this property, I can simply written log of x, that is x plus 1 divided by x plus 3 minus 5 by, here minus into minus plus into 1 by x plus 1 into some constant c. This is the solution of the given problem. Okay, let us move on the next one problem. Question number 36. Show that the position vector of the point R, which divides the line joining points P and Q, having the position vectors A and B internally in the ratio m is to n, is m into vector B plus n into vector A divided by m plus n. Okay, this is the question. Now I can solve the result here. First, have to consider. Okay. First, have to consider the diagram which here. Okay. Let us consider the first diagram. Okay. I can simply draw a vector diagram. This is 0 point from this one. There is a vector 0 to 8. Okay. Here the position vector. This is, sorry, 0 to 8. This is vector A and this is vector B. Now I can join A to B. Okay. Here is the vector position of P and Q having the vector, it can cut internally. So I can cut the internally in the ratio M is to N. This is the position vector R. 0 to B, there is a vector B, and 0 to A, there is a vector A. From the origin 0 to A, there is a position vector A. Okay. Here, first, let OA. Okay. Let the vector OA, that is vector A, and consider vector OB. The position vector OB can be represented by vector B and the position vector OP can be considered R vector. The point here, the point P. There is a point P. There is a point P. There is a point P which divides the line joining, which divides the line joining the points A and B. The points A and B internally. Okay, internally. Now I can consider here M into vector BP. So there is a point M into vector BP, M into vector BP or PB. So I can take M vector by its move on from A to B. That's why I'm taking BP. Again is equals to N into, so AP. N into position vector AP. Again, M divided by, taking N here, vectors are taken on right side. This is vector AP by vector BP. Now, what is the vector AP? AP can be written as, the vector AP can be written by using the vector property. Okay. By the vector property, what we written, the vector AP can be written as OP minus OE. Vector OP minus OE. Then N, here N can be written as OP minus OB. What is OB minus OP? Here, what is the vector OP represents here? Vector minus OE represents vector A divided by OB represents B minus vector r n by n. While again multiplying we want the position vector r, that's why I can multiply here. That is m into vector b minus vector r is equals to n into vector r minus vector a. We want vector r, that's why I am multiplying m into vector b, m into vector r is equals to n into vector r, n into vector. We want r vector, so I can take on here m into b. While taking minus here, it becomes plus n into vector a. That is taking minus m into position vector of r. On this side, it becomes plus n into r vector. We want r vector, so I can take comma. It becomes m plus n. Again on right side, the vector m into vector b plus n into vector a. We want the position vector r. It is m into vector b plus n into vector a divided by n plus n. This is the position vector a and b are internally having the points internally. This is the proof of the given statement. Okay. Now let's move on the question number 37. Derive the equation of the line in a space passing through the given point and parallel to the given vector in a form. Okay. Here, first I can draw an equation of the line in a space. First, here I can take, so I can take the rough diagram. This is x-axis, this is y-axis, and this is z-axis. Here, first we have to take. I can draw a graph here. Let here there is a point origin O. Taking the vector here, and that is position vector R. And again I can draw a point that is A. Okay. Now here I can join the here I can take the smaller one line. Okay, this is A point and this is a B point. Okay, there is a line here. This is here. Now taking the equation of line in a space passing through the given point and parallel to B. Here there is a vector L. Then I can draw parallel to this vector, that is called vector B. This is called vector B. So I can take on here all the points, then discuss one by one points. Here, let L be the equation of line in a space. Okay, equation of line in a space passing through the point A, passing through the point A with the position vector A. With the position vector A. Okay. Here there is a line L. There is a vector from 0 to A. Okay. So the line which is passing through the line A with the vector, position vector A. And here there is a point P. Let P be any arbitrary point. Okay. P be any arbitrary point in the plane. Arbitrary point on the line which with the position vector. With position. What is the position vector of the point P? That is R. Position vector R. Now, by these 2 points, what we written? The vector OA is equals to position vector E and the vector OP. The position vector is R. Now, vector B. Here there is a vector B is parallel to the line L. The vector B. The vector B is parallel to line L. Parallel to the line L. The position vector of B is parallel to the line L. Therefore, what we say? The vector or the vector AP is parallel to vector B. Parallel to the vector B. Therefore, I can written vector AP. Already know that although I already know the position vectors of AP. So, AP is equals to lambda into OP because they both are parallel to each other. So, the equation becomes vector AP is equals to lambda into vector B. Now, what is the AP? What is by the property of the vector addition? What is the AP? OA or OP minus OA. That is vector OP minus vector OA is equals to lambda into B. What is the OP? The position vector R. What is the OA? The position vector A is equals to lambda B. We want position vector of R, then it becomes vector A plus lambda into vector B. This is the vector form given state. Vector form of the given problem. This is the proof. Now, let's move on the question number 13. Okay, let's move on the question number 13. A man is known to speak truth 3 out of 5 times. Okay, there is a man out of 5 times he speak 3 times truth, 2 times false. He throw a die and reports that it is a 6. Find the probability it is actually a 6. Okay, we have to find the probability it's actually 6. Okay, don't it may true or false because the statement is truth or false statement because out of 5 times he say only 3 times truth, otherwise 2 times false. So we can solve here. First, let consider events. Let first event I can consider total. There is a die. It is occur 6. Okay. Let E1 be the event. Let E1 be the event that 6 occurs. Okay. that 6 occurs. And there is an event E2. Okay. The event that 6 not occurs. Here the chance is 6 occurs or 6 not occurs. He may say false statement. Okay. So what is the probability of an event 1? Okay. That is truth. Out of dice, 6 becomes only at once. Out of 6, 6 comes once, and out of 6 chances, 6 does not, that is 5 by 6. That is the events. Okay, probability of, this is probability of E2. Now, again, okay, now the man says, what he say? A be the event that man records the 6 occurs. Okay, here I can take another one event A. A be the event, A be the event that man records 6. Man records 6. Okay. What is the probability? Probability of A on event A. It means condition probability. A be the event that man records 6. Okay. Total, there are 5 statements. Out of 5, 3 times he was say truth. So the man reports 6 out of 5, he reports 3 times. Then there is a another one condition 6. Here the event that man does not man does not report 6. Man does not report 6. What is that? The condition A on E2. That is out of 5 times, it 2 times not report as a 6. Okay. So what is the actual? Okay. That is what is the actual probability? Okay. That is actual probability. Actual probability of 6 is actual probability of 6 is actual probability of 6 is, that is probability of event 1. So by A, event 1 by A, it becomes, the statement says that the probability that the report of the man 6 as occurred is actually a 6. Okay. Actually 6 is how much times? We have to calculate now. That is probability of A1 event. What is this? The truth event. 6 occurs into condition probability of A divided by an event 1 divided by probability of E1 into probability of A by E1 plus probability of E2 into probability of A of E2. So substitute all the values. What is the probability of E1? 1 by 6 into probability of AV1 354. Here 1 by 6 plus, sorry, multiplication. It is into 355 plus E2 5 by 6 into 2 by 5. Now calculate here. 5 get cancelled. 2 ones are 2, 3 are. Here 3 ones are 2, 2 are. So multiplication 3 ones are 3 twos are. 1 into 3. 1 by 2 5s are 10 divided by 1 by 10 plus here 1 by 3. Now calculate. It becomes here, that is 3 into 1. 3. 1 by 10 divided by multiplication or taking LCM. This is 3 plus 10 divided by 30. While taking the cross multiplication, it becomes 1 by 10 into 30 by 30. 3 by 10 is a 3 is a. Then the answer becomes 3 by 13. Out of 13 times, he said the truth is 6. That is actually 6. Okay. Up to this much, the question number or the part C is completed. Okay. Let's move on the part D. Okay. Here, part D. Mainly the part D containing 7. Answer any 4 questions. There are 7 questions are there for 5 marks. For 7 questions, we have to solve any 4 question. Okay. We have to solve any 4 question. Each 4 questions carries 5 marks. Then that is 20 marks. Overall from part D, we want take 20 marks in this session. Okay. There is a first question in this session, that is question number 39. Consider the function f from a tends to b defined by f of x is equals to x minus 2 divided by x minus 3. If f is 1, 1 and on to justify your answer. Where a is, okay, where a is a real number minus 3. It means except 3. We have except 3, we will get the real number. And for the set B, except 1, we have to take all the real numbers. Okay. First, considering the function, let f of x is equals to x minus 2 divided by x minus 3. Okay. Now, we have to prove the given function is 1, 1 and onto, or we have to check the 1, 1 and onto. First, I am considering one condition, that is 1. Let's consider the function, that is f1 f of x1 is equals to f of x2. Here the function is f of x1 is equals to f of x2. They given already f of x is equals to x minus 2 divided by x minus 3. Wherever x is there, we have to take the x1. That is x1 minus 2 divided by x2, x1 minus 3. That is equals to x2 minus 2 divided by x2 minus 3. Taking the cross multiplication here, that is x1 minus 2 into x2 minus 3, that is equals to x2 minus 2 into x1 minus 3. Taking the multiplication x1 into x2, that is x1 x2 minus here x1 into minus 3 minus x1 minus into 2 x2 minus into minus, that is plus. Here also taking the multiplication, that is x1 into x2 minus 3 into x2. Similarly for minus 2 x1 and minus into minus plus 6. Here comparing the LHS and RHS, plus 6 get cancelled. X1 and x2 get cancelled. Here we have minus 3x1 minus 2x2 is equals to minus 3x2 minus 2x1. I am taking x1 on left side, that is 3x1. Here there is a minus 2x1. Taking left side, it becomes plus 2x1 is equals to minus 3x2. Okay. Taking minus 2x2 on right side, it becomes plus 2x2. Taking the minus and plus 2, it becomes minus x1 is equals to minus x2. While cancelling the minus symbol, x1 is equals to x2. That is, for every x1 and x2 are belongs to x. Okay. Here the function x is a. Okay. That is, x1 and x2 are belongs to the real number r minus 3. Okay. Hence, by this condition, we say f is 1. F is 1. Similarly, I am checking the second condition. F is onto. Okay. That is, let f of x is equals to x minus 2 divided by x minus 3. Here taking f of x is equals to y. That is, y is equals to x minus 2 divided by x minus 3. Okay. Now we have to solve for x. Okay. Have to solve for x. So I am taking the cross multiplication, that is y into x minus 3 is equals to x equals to. Here also taking multiplication with yx minus 3y is equals to x minus 10. We want only x. Okay. Now I am solving for x. That's why taking this minus x on plus x on left side, it becomes minus x. Yx minus x is equals to taking plus 3y on right side, it becomes 3y minus 2. We want x only, taking x as a common, y minus 1 into 3y minus 2. And that is, x is equals to 3y minus 2 divided by y minus 1, which is belongs to the real number r minus. Okay. Hence, by this condition, yes, by condition or by definition, hence by the definition of function, what we say, f is, f is 2. Therefore, from the above result, what we say, from the results, from the result, we say f is 1 and unto f is 1 and out. And also then there exists a inverse. Then there exists a inverse, that is f inverse of, here the x will be the on the value of x, that is the f inverse of y. Okay, that is f here while taking the f of x. Okay, that is f of x is equals to y. Then taking f here, it becomes x is equals to f inverse of y. So I can write f inverse of y will be y minus 2 divided by y. So to this much, this is the proof of the given problem. Okay. F inverse of y is equals to 3y minus 2 divided by y minus 4. Hence, the given function is 1 as well as 1 2. Now, let's move on the question number 40. Okay. Here, if A is equals to a matrix containing 3 rows, 1 column, that is, I can return the order 3 cross 1. Here there is a matrix D. This is 1 row, 3 columns. This is 1 cross 3. So we can verify the given condition. First, have to take the LHS part. Okay. That is, first I am considering only A into B matrix. What is the A matrix? The elements 1 minus 4 and 3. Here the B matrix containing the elements minus 1, 2, 1. Have to take the multiplication row by column. 1 into minus 1 minus 1. So 1 into 2, 2, 1 into 1 minus 4 into 1 becomes 4. Minus 4 into 2 minus 8. 4 ones are 4. Here minus is there. 3 minus 1 minus 3. 3 twos are 6. 3 ones are 3. Okay. This is the AB matrix. We watch AB transpose matrix. The LHS part is AB transpose. Taking or interchanging the rows and columns, we will get the transpose matrix. Taking this row as a column minus 1, 2, 1, 4 minus 8 minus 4 minus 3, 6, 3. Okay. This is the one, that is LHS part. Now I'm going to take the RHS part. Thus it is B transpose. What is the B transpose? Row, I'm taking row as a column. Minus 1, 2, 1. Okay. And A transpose will be, what is the A transpose? Taking column as a row, 1, 4, 3. Okay. While multiplication, the RHS part is B transpose into A transpose, that is equals to minus 1 to 1 into 1 minus 4, 3. Taking row by column. Here the multiplication is minus 1 into 1, 1. Minus 1 into 4 plus 4. Minus 1 into 1 minus, okay. Minus into minus plus 1 4 is 4. Minus 1 into 3 minus 2. 2 1 is 2, 2 4 is 8. And 2 3 is 6. 1 1 is 1. 1 4 is minus 4. 1 3 is 3. Okay. This is equation 2. What we say from equation 1 and 2. That is LHS is equals to RHS. LHS is equals to RHS. Therefore, AB transpose is equals to B transpose into A transpose. This is the proof of the given problem. Okay. Let's move on the question number 14. Use the product. Okay. Here they given two matrix. This is one matrix and this is one. When we take multiplication of these two matrix, by using these product matrix, we have to solve the system of equation. Okay. Here x minus y plus 2z is equals to 1. 2y minus 3z is equals to 1. 3x minus 2y plus 4z is equals to, here 4z is equals to 9. Okay. Now let's solve the problem. Sorry, here in this question, this is 2, not 9. Okay. This is 2, not 9. Now, first, let us consider the system of equation. Let us consider the system of equation. Let us consider the system of equation can be written here by using the system of linear equation. I can write the A matrix first. The elements coefficient of x will be 1, y is minus 1 and z is 2. Okay. Here there is a x is not present, so I can take 0, that is 2. Here 2 and this is minus 3. Similarly 3 minus 2, 4. Okay. Now similarly I am taking the B matrix. The values are the resultant values 1, 1, 2 and there is a x. that is X, Y, Z. The X matrix contain X, Y, Z. Now I can consider in the product because we have to using the products. So by the product of matrix by the product of matrix I can consider here. Okay, that is 10 means 1 minus 1, 2, 0, 2 minus 3, 3 minus 2, 4. Here minus 2, 0, 1, 9, 2 minus 3, 6, 1 minus 2. Now I can take the multiplication here, that is row by column. First row, first column, 1 into minus 2, that is minus 2, minus 1 into 9, minus 9, 2 into 6, that is plus 12. Similarly, first row, second column, 1 into 0, 0, minus 1 into 2, minus 2, 2 ones are plus 2. Here, first row, third column, 1 ones are 1, minus 1 into 3, plus 3, and 2 twos are 4, that is minus 4. First row is completed. Next, second row, first column. 0 into 2, 0. 0 into anything will be 0. 2 nines are 18. Here, minus 3 into 6, minus 18. 0 into 0, 0. 2 twos are 4. And minus 3 into 1, minus 3. 0 into 1, 0. 2 minus 3, that is 6. And 3 twos are 6, that is plus 6. Here 3 into minus 2, minus 6. Minus 2 into 9, minus 2 into 9, minus 18. 4 6 are 24. That is last row by second column, 0 plus minus 2 into 2, that is minus 4. Again 4 ones are plus 4. 3 into 1, it is 3. Minus 2 into 3, that is minus 6. Minus 2 into minus 3, that is plus 6. 4 twos are minus 8. Okay, now I can solve this one. Here minus 2 minus 9 plus 11 minus 11 plus 12. This is 1. Here this one get cancelled. Plus 4 minus 4 get cancelled. You will get 0, 0. Here plus 18 minus 18 get cancelled. That is 0, 1. 4 minus 3, 1, 0. Similarly, minus 6 minus 18, 24. And this 24 get cancelled. You will get 0. Here minus 4 plus 4, 0. 3 plus 6, 9, 9 minus 8, 1. Okay. When we take the product, we will get the identity matrix. That is, while comparing the, that is, comparing the matrix, comparing the product matrix, comparing the product matrix. Here, this matrix represents the A matrix. Okay. So this matrix represents the A matrix. A into A inverse, you will get the identity matrix. So comparing the product matrix, so we can write the result A into A inverse is equals to I. So we get easily by taking the product, we have A inverse, that is minus 2, 0, 1, this matrix, 9, 2, minus 3, 6, 1, minus 2. So we will get directly A inverse. Now we can easily solve the system of equation. Then the system of equation can be written. The system of equation can be written. Can be written. What we written? That is X is equals to A inverse into B. So directly I am taking X matrix. What is the A? Minus 2, 0, 1, 9, 2, minus 3, 6, 1, minus 2 into what is the B matrix? It is B matrix containing elements 1, 1, 2. Okay. So taking the multiplication, you will get minus 2 row by column, minus 2 into 1, minus 2, 0 into 1, 0, 1 into 2, plus 2. Here 9 ones are 9, 2 ones are 2, minus 3 into 2, minus 6. 6 ones are 6, 1 ones are 1 minus 2 into 2, minus 4. So x is equals to minus 2 plus 2 get cancelled. We will have 0, 9 plus 2, 11, 11 minus 6, 8, 5, 6 plus 1, 7, 7 minus 4, that is 3. While solving the system of linear equation, what we written? X is equals to 0, y is equals to 5, and z is equals to 3. This is the solution of the given problem. X is equals to 0, y is equals to 5, and z is equals to 3. Now, let's move on the question number 42. Find the values of a and b such that f of x is equals to 5 if x is less than or is equals to 2, ax plus b if 2 is less than x less than 10, 21 if x is greater than or is equals to 10, where x is continuous function. Okay, here there are two continuous points are given. Okay, we can consider in the two verbs. Okay, two continuous functions. One is checking for 2 as well as checking for 10. Okay, here first I can take, let consider the function. Let consider in the function f is equals to 5. F is equals to 5 if x is less than or equals to 2, ax plus b if 2 is less than x less than 10, and 21 if x is greater than or is equals to 10. We already know the definition. Like definition of the by the definition of continuous function, what we written by the definition of continuous function, we can written the LHS part, that is left hand limit. Limit extends to, okay, limit extends to c minus f of x is equals to limit extends to c f of x is equals to limit extends to c plus f of x, all are equal. By the definition, what we say, the left hand limit, right hand limit, and the given function is equal. Okay, now check the condition for at point 2, at x is equals to, okay, here for this x, taking the condition at x is equals to 2, and here x is less than 2, x is greater than 2. What is the function at x is equals to 2? That is x is 2. The given function is 5. Then at x is less than 2, the given function is 5. Here also 5. When at x is greater than 2, we will get ax plus b. While taking the definition, the left hand limit and the given functions are equal. So I am taking directly limit extends to c minus f of x is equals to limit extends to c plus f of x. Okay, here at x is equals to 2, I am taking limit at x is equals to 2 minus f of x is equals to limit at x is equals to 2 plus f of x. Wherever the function f of x, okay, taking f of x, what is at 2 minus the given function is 5. While substituting, okay, while substituting the given function 2 plus f of x, we will get wherever x I can substitute 2, it becomes 2 into a plus b. This is equation number 1. Similarly, at x is equals to 10. Here also I am taking a function at x is equals to 10. The given function is 21. At x is equals to 10. Then x is less than 10. It becomes ax plus b. At x is greater than 10. It becomes 21. So I can directly taking the definition limit x tends to c minus f of x is equals to limit x tends to c plus f of x. Here I can substitute at c is equals to 10. That is limit x tends to 10 minus f of x is equals to limit at x is equals to 10 plus f of x. So here the function is f of x is ax plus b. Limit x tends to 10 minus ax plus b is equals to limit x tends to 10 plus f of x is 21. While substituting the value, we will get what is the value of x is 10. That is 10a plus b is equals to 21. From equation 1 and I can solve here from 1 and from 1 and 2. Here directly I am taking 2a plus b is equals to 5 and then a plus b is equals to 21. I can take the subtraction here. That is, by the subtraction, b will get cancelled. 2a minus 10a, it becomes 8a is equals to 5 minus 21 minus 16. So, minus minus get cancelled. 8 ones are 8 twos are. So, a becomes 2. Okay. A value becomes 2. While substituting the a value in the any one equation, I am taking a is 2 is in equation 1. That is 2 into a plus b is equals to 5. B is equals to taking 2 into 2 4. 5 minus 4. The value of b is equals to 1. Here a is 2 and b is 1. Therefore, the values of a and b, the values of a and b are 2 and 1 respectively. This is the solution of the given problem. Let's move on the next question. Question number 43. Find the integration of 1 divided by x square plus a square with respect to x, and hence evaluate the integration 1 divided by root of x square plus 121 into dx. Okay, here I am considering the integrating part. Integration, that is 1 divided by root of x square plus a square dx. Okay. Here we can't solve directly by using the formula. So first have to take any substitution here. Okay. So for that substitution I am taking here I am taking x is equals to, okay, while substitution I am taking x is equals to a tan theta, because we know the formula, that is x square plus a square. Here while substituting the formula, tan square plus 1 is sec square. So I can directly getting the solution and taking the x as a tan theta. So taking the differentiation, that is dx is equals to a. Differentiation of tan theta will be sec square theta into d theta. So taking these results in this equation while substituting 1 divided by replace x by a tan square tan theta, that is a square tan square theta plus a square. Here there is a dx, so I can take dx as a sec square theta into d theta. Now a sec square theta into d theta divided by, here both side containing a, so I can directly taking a square as a constant, it becomes tan square theta plus 1. We know the standard result. Okay, the standard result of the trigonometry, that is 1 plus tan square theta is equals to sec square theta. By using these standard results, I can directly return the a sec square theta d theta divided by root of a square. So I can directly taking tan square theta plus 1 is sec square theta. Okay, here both containing the square parts, so I can taking separately as a squares, that is root a square root of sec square theta. Square root get cancelled. Here also square root get cancelled. We will get the result integration a sec square theta divided into d theta divided by a into sec theta. A get cancelled. Here square and sec theta get cancelled. You will get the sec get cancelled. We will get the integration of sec theta d theta. Okay. What is the integration of sec theta? That is integration of sec theta is equals to log of tan theta plus log of tan theta plus sec theta some constant. What is the integration of sec theta will be log of tan theta plus sec theta. So I can take in here the formula integration, that is log of sec theta plus tan theta with some constant c. So we can take the here the result can be written in the form of x and a. The result can be expressed in the form of x and a. So by using this result, what we written tan theta. Tan theta can be written as taking a here, that is denominator, that is x by a. Similarly, by can use this result. So directly substituting the tan values, that is 1 divided by x by a. Tan will be x by a. Here tan square is then x by a whole square is equals to sec square theta. Now, here one splitting x square by a square is equals to sec square theta, while multiplication taking LCM, a square by x square divided by a square is equals to sec square theta. We want sec theta, so root of a square plus x square divided by a square. While taking the root as a common, a square by x square divided by root and square get cancelled. So I can return a. While substituting the values here, log of what is the sec theta? So it can be written as a square plus x square or x square plus a square divided by a plus. Here what is the tan theta? By using this one, I can return x by a plus some constant c. So I can taking here both denominator containing a, I can taking log of root x square plus a square plus x minus log a, because I am using the Law of indices. Logarithmic function log n divided by log n can be written as log m minus log n. By this property, I can take a as a constant, log a plus c. So log brings to as a constant, what we written log of root x squared plus a squared plus x with some constant c. This is the given result of the integral. That is integration of 1 divided by root of x squared plus a square is equals to what we written log of root x squared plus a square plus x plus some constant c. This is the solution. So proof of the integral. Now evaluating this one result. Okay. Here I can take. Okay. Here I can take the result here while solving the results. Okay. I can solve the result here. Now integration 1 divided by root of x squared plus 121. 121 can be written as 11 square. So I can substitute here the values that is integration of 1 divided by x squared plus 121 can be written as log of. Here substitute all the wherever a square is there we can take 121 while comparing log of root x squared plus 121 plus what is the x? That is 11 square, x becomes 11 plus some constant. So this is the solution of the given problem. Up to this much, have to solve for 5 minutes. Let's move on the next question. Question number 44. Find the area of the region bounded by the ellipse. X squared by 16 plus y squared by 9 is equals to 1. Here I am taking the rough diagram for ellipse. Okay. Here this is x-axis, y-axis. Okay. For this one, there is a 4 units are there. Why I am taking 4 units? Here, x represents the major axis. X represents the major axis and y-axis represent the minor axis. So 16 can be written as 4 square and 9 can be written as 3 square. By this results, I can directly take here there is a origin. Origin to x-axis will be 4 units. Here this is units. Okay. Now we have to find the area of bounded by the region. Here I am taking this part. So here you can solve for x or else you can take the y-axis. That is area of ellipse. Okay, area of ellipse. I can considering the only one part. All 4 parts are equal. Therefore, 4 into integration of 0 to 4 y dx. Because I am taking with respect to x-axis. I am taking with respect to x-axis. That's why the limit value is taken 0 to 4. Or else you can take along the y-axis also. So while solving this equation, you will get the 1. What is that? X squared divided by 16 plus y squared by 9 is equals to 1. We have to solve for y. That's why I'm taking y squared by 9 on left side. Taking this one on right side, it becomes minus x squared by 16. So taking LCM, y squared by 9, that is 16 minus x squared divided by 16. We have y squared here, a multiplication 9 into 16 minus x squared divided by 16. So taking 16 as common, that is 9 by 16 into here taking 16 minus x squared while taking square roots. That is y is equals to square root of 9 will be 3, square root of 16 will be 4. That is 16 minus x. Okay. So what is the value of y? While solving this one, I can substitute here directly. That is 4 into what is the 0 to 4. What is the value of y? Y will be 3 by 4 into root of 16 minus x square into x. I'm taking 3 by 4 as a constant, that is 3 into 4 into 3 by 4 integration 0 to 4 root of 16 minus x square into x. 4 get cancelled. So here there is a 3. Now I can take 3 into integration 0 to 4 root of 16 minus x square into dx. Again, we already know the formula, that is integration of a square minus x square. That is a square minus x square will be x by 2 root of a square minus x square plus a square by 2 into sine inverse of x by a plus some constant c. This is the rule of the integration a square minus x square. So I can substitute in the integration, that is 3 into taking direct result x by 2 root of what is the a 16 x square plus a square, that is 16 by 2 sine inverse of x by what is a 4. Okay, square root of 16 will be 4 plus here there is a lower and upper limits are there. It means definite integral. So I'm taking the upper limit as well as lower limit. First, I can take the upper limit as a constant. First, substituting the upper limit wherever x is there, taking 4. That is 4 by 2 root of 16 minus 4 square will be 16. It becomes 0. Okay. Plus 16 by 2 and sine inverse of what is the x? X become 4. 4 divided by 4 while taking minus the lower limit. Taking 0, the whole equation will be 0. Okay. While solving this, 3 into 2 ones are 2, 8s are 8 into sine inverse of 4 get cancelled. Sine inverse of 1 while solving this 3 into 8. What is the sine inverse of 1? Pi by. While solving this one, 2 ones are 4s are. So 3 into 4, 12 pi square units. The area of the region bounded by the ellipse is 12 pi square units. Now let's move on to question number 45. Solve the differential equation y into dx minus x plus 2y square dy is equals to 0. Okay, let's consider the equation of the differential equation, that is y into dx minus x plus y square dy is equals to 0. Okay, now to solve for separating dx and dy on separates. So y into dx, here minus taking on right side, it becomes plus x plus y square dy. Okay, here we want dy by dx. So I am taking Here dx by dy. Dx by dy is equals to, taking y here, it becomes x plus 2y square divided by 1. Now taking y separately, dx by dy is equals to, subtracting, it becomes x by 1 plus 2y square divided by 1. Square y get cancelled. We have dx by dy is equals to x by y plus 2 into the equation of the form. The equation of the form, the equation of the form dx by dy minus, here it can be written as, okay, dx by dy minus dy, that is here dx by dy. Here taking x on this side, it becomes, here this is x y is equals to 2y. This is of the form dx by dy plus dx is equals to q. While comparing equation 1 and 2, comparing 1 and 2, what we written, comparing 1 and 2, we written p is equals to, that is p is equals to minus 1 by y and q is equals to 2. Now taking integrating factor, that is e to the power integration of p into dy. That is integration of, what is the p? That is minus 1 by y dy, taking minus as a constant, integration of 1 by y dy. It is e to the power minus log 1. So it can be written as integration of log 1 by, we know the result, e to the power of log y will be y. So directly I am taking integrating factor is equals to 1 by 1. Okay. Integrating factor is equals to 1 by 1. Now taking one this, the solution is x into integrating factor, x into integrating factor is equals to q into integrating factor into y plus some constants. Okay. Here x, what is the integrating factor? That is 1 by y is equals to q. What is the value of q? Here 2 y into integrating factor, that is 1 by y some constant c. This y get cancelled. Here this is dy. Okay. dy y get cancelled. X into 1 by y is equals to integration of dy plus some constant. 2 as a constant. Integration of 1 with respect to y will be 1. That is 2y plus constants. This is the solution of the given differential equation. Okay. Now let's move on the next question. Up to this much, the part D completed. Now let's move on the part E session. Answer the following questions. Mainly the part E questions containing 6 and 4. Okay. Here there are 2 questions for 6 marks and 2 questions for 4 marks. You can solve any one out of these 2 questions. Here also you can solve any one question out of these 2. Okay. Then for this section, you have to take the 10 minutes. Okay. Now answer the following question. The first question have to prove that integration of a to b f of x into dx is equals to integration a to c f of x dx plus integration c to b f of x dx, and I'm evaluating integration from -1 to 2 mod of x cube minus x into dx. Okay, let's consider let's consider the definition of let's consider the definition of definite integral. Okay, definition of definite integral here, that is integration of a to b f of x dx is equals to f of upper limit minus lower limit. This is equation number 1. For this one, I can written a to c f of x dx is equals to f of here a, sorry, f of a. This is the upper limit c minus lower limit 2, and the third one c to b f of x dx is equals to f of the upper limit will be b minus lower limit f of c. This is equation number 3. Now I can considering the right hand side, that is RHS. Now I can considering the RHS part, that is integration a to c f of c dx, sorry, f of x dx plus c to b f of x dx. That is, by applying the definition, what we written, the upper limit minus lower limit plus upper limit minus lower limit. Okay, f of c get cancelled, then minus f of a plus f of a. So it can be written f of b minus f of a. While comparing equation 1, we can written integration a to b f of x dx. So this is the LHS. Therefore, of LHS is equals to RHS. Okay. From the result, what we written, LHS is equals to RHS. Therefore, the result will be proved here. That is, integration equal to b f of x dx can be written a to c f of x dx plus c to b f of x dx. Now I can evaluating the integration now. Here I can solve the problem. Let integration -1 to 2 x cubed minus x dx. So first, while considering the x cubed minus x, can be taken this one. It is taken x cube is equals to x get cancelled. So x square is equals to 0. So I can take the root x have the two values. So 1 and -1 are taken. The interval can be split into 3 intervals. That is equals to -1 into 0 f of x dx plus 0 to 1 f of x dx plus 1 to 2 f of x dx. Okay, what is the integration of x cube minus x? What is the integration of x cube minus x? That is x to the power 4 divided by 4 minus x squared by. This is the integration of this one. So I'm taking directly the limits 0 to -1 plus here x to the power 4 divided by 4 minus x squared by 2, 0 to 1 to minus 1 to 0, here 1 to 0. That is again plus x to the power 4 divided by 4 minus x squared by 2, the upper limit to lower limit. Now substituting the upper limit, the whole equation will be 0 and minus lower limit. While taking the lower limit minus of minus to the power 4, minus 1 to the power 4, 1 by 4. Here minus square will be plus 1 by 2. Again plus, while taking the upper limit 1 by 4 minus 1 by 2. While substituting the lower limit, it becomes 0 plus. Here substituting the upper limit 2 to the power 14. It becomes 16. 16 by 4 minus 2 squared 4 by 2 minus of, while taking the lower limit x4, that is 1 divided by 4 minus 1 by 2. Taking all the values here, minus 1 by 4 minus 1 by 2. So while taking minus 1 by 4, minus into minus plus 1 by 2 plus 1 by 4. Here plus into minus, minus 1 by 2 plus 4 ones are 4 fours are 4. Here 2 ones are 2 twos are 4 minus 2 minus 1 by 4 minus into minus plus 1 by 2. Minus 1 by 4 plus 1 by 4 get cancelled. 1 by 2 minus 1 by 2 get cancelled. 4 minus 2, that is equals to minus 1 by 4 plus 1 by 2. While taking the LCM, you will get 4. That is 2 fours are 4 ones are 2 twos are 4 twos are 8 minus 1. Here 1 twos are plus 2. Okay, it becomes. So I will find it somewhere. Here the limit value will be minus. This is also minus. Okay. 8 plus 1, 9, 9 plus 2, 11 by 4. This is the result of the given problem. Okay. With the another one 6 marks problem, you can solve this LPP problem or else integral part. Solve the following problem graphically, maximize and minimize the optimal equation z is equals to 3x plus 2y subject to the constraint x plus 2y less than 10, 3x plus y less than 15. Okay. Now let us consider in the equations here x plus 2y less than or is equals to 10. Now taking the x and y values generally, while putting x and put x is equals to 0. Here in this equation, y becomes 5. Again, while substituting y as a 0, you will get, okay, put x is equals to 0, you will get y value. What is the y value? It becomes 5. Put y is equals to 0, then the x value becomes 10. Okay, x value becomes 10. Similarly, for second equation 3xy less than 15. Here also checking the condition while taking the x and y is equals to 0. Put x is equals to 0, y value becomes 15. Again put y is equals to 0, then x value. Put x is equals to 0, then y becomes 15. Again, here putting y is equals to 0. Putting y is equals to 0, what is the value of x? It becomes 5. Now I can take the rough diagram for the graphical representation. So here I'm taking the diagram. This is x-axis and this is y-axis. I can taking the units 2, 4, 6, 8, 10, 12, 14, 16 up to this much. And here 2, 4, 6, 8, 10. Those the scale x axis will is taking units and y axis 1 centimeter is equals to 2 units. Both are taking 2 units. 1 centimeter is equals to 2 units. Now, while taking these values in the equation, here put x is equals to 0, then put x is equals to 0, then y becomes 5. Again put x is x become 10, y is 0. So I can draw the diagram here. Similarly, for the second graph, put x is equals to 0, y becomes 15. Here, again put x is equals to 5. Then y-axis will be 0. The diagram here. Okay. Now, this is the part. Okay. This is the visible region. That is the visible region. When you plot the graphical representation in graph, you will get the results accurately. Okay. Now by the graph, what we say, this is the point A, B, C. The graphical presentation shows the bounded region. The bounded region O in B, C. Okay. Then it is bounded. It is bounded. Therefore, the corner points. What are the corner points? Called Z. Z is equals to, here first I am taking the corner points here, the corner points and the Z value. Z is equals to 3x plus 2. What are the corner points at origin? 0, 0, 0 and 8. Here at x is equals to 0, y becomes 5. Here it cuts. Okay, this graph cuts when you take the graphical representation. When you take the graphical region, you will get the 4, 3. X is okay. X is equals to 4 units and y becomes 3 units. Okay. Then C point is here, that is 5, x is 5 and 0. Okay. So here the graph is taken here. Okay, not like this. The graphical represent shows here because right, the 5 here cuts here, that is 4 comma 3. The points B here it shows the 4 comma 3, that is 0 comma 5. B is 4 comma 3 and C 5 comma 0. For this one, we have to take the corner points. Put x is equals to 0, y is equals to 0, the result becomes 0. The result is here, 3 into 0 plus 2 into 5, it becomes 10. Z is equals to 3 into 4 plus 2 into 3. 3 4s are 12, 12 plus 6, 18. And Z is equals to 3 into 5 plus 0, it becomes 15. Z attains minimum. Z attains minimum at 0. Z attains minimum at 0 and maximum at 18. So I can return, therefore the maximum value is the maximum value of Z attains 18. Z attains 18 at the point B contain 4 comma 3, and the minimum value of Z attains 0 at verging on 0 comma 0. This is the solution of the given problem. Okay, let's move on the 4 marks question. Question number 47. Okay, show that the matrix A is equals to the elements containing the matrix 5, 6, 4, 3, satisfying the equation A square minus 8A minus 9I is equals to 0. Okay, now let's consider the equation A in the matrix A containing the elements 5, 6, 4, 3. While taking the multiplication, it becomes A square is equals to A into A, that is 5, 6, 4, 3. Taking the multiplication 5, 6, 4, 3. Taking multiplication row by column, it is 5 5 is 25 plus 6 3 is row by column, 6 4 is 20, 5 6 is 30 plus 6 3 is 18, 4 5 is 20, 3 4 is 12, 4 6 is 20, 4 plus 9, it becomes 25 24, 49, 30 plus 18, 48, 32 and 24 plus 9. 24 plus 9, it becomes 33. A square is equals to 49, 48, 32, 33. The equation is A square minus 8 into A minus 9 into identity element. So I can substituting the values here. It is 49, 48, 32, 33 minus 8 into A matrix 5, 6, 4, 3 and the identity matrix 9 into 1 0 0, that is 49, 48, 32, 33, 8 5s are 40, Here 48, 32, 24 minus 9009. Okay, here 49 minus 14, 9 minus 9, that is 0. 48, 48, 0. 32 minus 32, 0. 33 minus 24, 9, 9 minus 9, 0. This is the 0 matrix. Therefore, a squared minus 2a minus 9i becomes 0 matrix. Now, taking by using the equation a squared minus 8a minus 9i is equals to 8. Okay. While multiplying a inverse on whole equation, it becomes a inverse into b squared minus a inverse into a minus 9 into a inverse into identity is equals to 0. A inverse into a square becomes a minus a inverse into a, it is identity. 8 into identity minus 9 into a inverse is equals to 0. We want a inverse, taking minus a inverse is equals to 8 into identity minus a matrix. I am taking 8 0 0 8 minus what is the A matrix? 5 6 4 3. It becomes 5 minus 8 minus 5, that is 3. 0 minus 6 minus 6, 0 4 minus 4, 8 minus 3, it is 5. Minus 9 A inverse. We want A inverse. Therefore, minus of 1 by 9 into 3 minus 6 minus 4, 5. This is the solution of the given problem. Now, let's move on the last question for another one, 4 marks. Differentiate sin x to the power x plus sin inverse of x with respect to x. Let I considering whole equation as a y, that is sin x to the power x plus sin inverse x. Differentiate with respect to x. Okay, it becomes dy by dx is equals to d by dx of sin x to the power x plus d by dx of sin inverse x. Here, while taking the sin x to the power x becomes of, so I can take here separately, taking this one as a t. So I'm applying the logarithmic function because there is a power function taking log on both sides. If log on both sides, it becomes log of sin x to the power x is equals to log t. So by the property, I can take log x into log sin x is equals to log t. So differentiate with respect to x. So taking these as a product rule, first function constant, differentiating the second function d by dx of log sin x plus log sin x into d by dx of x is equals to d by dx of log t. Okay. Here, while differentiating, differentiation of log will be 1 by x. Here, log of sin x. In place of x, we have sin x. That's this 1 divided by sin x. So, differentiation of sin x will be cos x plus log of sin x. Differentiation of x with respect to x will be 1 This is 1 by t dt by dx. We have 1 by 2 dt by dx is equals to x cos x by sin x cot x plus log of sin x. We want dt by dx. So taking t, what is the value of t? That is sin x to the power x into x cot x plus log sin x. Okay, so I can substituting the value here. It becomes sin x whole to the power x into x of cot x plus log of sin x plus what is the differentiation of sin inverse x? That is 1 divided by root of 1 minus x squared. Okay, here this is the dy by this. Up to this much, the solution of the whole model question paper will be completed. Okay, the model question paper 2 will be completed. Okay, if you have any doubt regarding this session, please comment on comment box. After watching this video, please like and share to your friends. Thank you everyone.